Hey, by the way, I do have your quizzes. I don't know why I'm putting this on the recording. No one cares, but I do have your quizzes done. They're in the grade book, FYI, but I'll get them back in your physical possession before long. They're not done because I have like three people that haven't finished both days yet. So, but if you want to know what you got, the score is still out of 70. Um, no one did worse. Everyone that I've finished so far did better. Some were significant, like 20 points better. Some were like 5 points better. But they're all better. So that's good news. Anyhow, let's get to it. Today is the 7th, and today we are going to talk about, I'll tell you what that word is after I get this out. I need you to put your phones away. All right. If you don't, oh my goodness. Okay. Seriously? Okay. So yeah, that word is recursive. And what the first few minutes of this, I always am careful when I explain something that I had a hard time understanding myself. So I'll try to choose my words very delicately for you. So what you guys have been working on have been explicit formulas. And I wouldn't write this down if I were you. I just want to kind of give you some background so you understand where we've been. So an example of an explicit formula is something like this. I wouldn't write it down if I were you, because then you might think that this has, like, this is what we're doing today. Um, and I don't want that. I just want you to kind of see where we've been so that maybe you'll understand a little bit better where we're headed here. This is an explicit formula. And what's beautiful about an explicit formula is, assuming you've been doing all your practice work, you should know by now that if I said to you, find the 37th term, you could. And I know it might take a little warm up, but here are some options for you. Option one is to go like crazy old school and say, okay, I know from that with the arrow that the first term of the sequence is 4. Can you guys tell me what it goes up or down by each time? Just look at the formula that I gave you. Want another hint? It goes up by 7 each time, right? We come to recognize with an explicit formula that this formula is so rad because it gives me everything that I need to go anywhere that I want to go. If I said to you, find the 37th term in the sequence, option one, if you're feeling totally crazy, is you could go like this. You could go, okay, 4, and it goes up by 7. So the next term is 11. The next term is 18. The next term is 25. The next term is 32. The next term. But really, who would do that, right? Other than a crazy person. So, I mean, that's an option. But the real beauty of a recursive formula is that if I want the 37th term, I don't need to count out all 37 of the first terms. I need to use the dang formula, right? And remember that we had a formula and it just simply said that you just, you put in a certain number for n and you're good to go. If I'm finding the 37th term, that just means you put 37 right there and you're done. You grab a calculator and you're done. Explicit formulas, you don't probably see it from this perspective, but you will after I annoy you with the new stuff, especially tomorrow's stuff. You can be like, I really miss those nice explicit formulas. So what it would say is this, okay, so you want the 37th formula? I got you. It's 4 plus 36 times 7. And the 36, of course, came from doing 37 minus 1. So I type into my happy little calculator that, and what's that? 210, 250, 256. So rather than having to write it all out, the explicit formula is so appreciated because it gives me anything I want. How long would it take me to find the 145th term? That's right, exactly as long as it took to find the 37th term, right? I don't have to write out a whole list of them like a monkey. The recursive formula is a little bit more difficult than this. Explicit's nice. So having said that, I'm going to show you an example of an explicit formula, and we're going to talk very candidly about why it's not as enjoyable as an explicit formula. And I'd really like it before you leave here today, if you could kind of try to get your head around what it is that really separates the two. What does the recursive allow me to do, and what does the explicit allow me to do? Explicit's always better, FYI. So here it is. I would start writing this down now. So here's an example of an explicit formula. Are you ready? And there's a 90 something percent chance that in about a minute you're going to be looking at me like, okay, I don't know what you're talking about. And I want you to know ahead of time that that's totally normal for this. Okay. Here's why a recursive formula is less useful. It doesn't give us the ability to go right in. And I'll tell you, if you think about, let me try to translate something for you. I'm gonna write something here, and I might unwrite this in a second if I don't like the way it comes out. But what that yellow box says is this. Every term is 8 more. That's what the yellow box is telling you. And you can see it that the part that's going to confuse you is the n minus 1. And we'll talk about that here in a moment. But that's always what bogs kids down with this is the n minus 1. And I'll explain it. But the plus 8 at the end is the behavior. The plus 8 is what describes the behavior of the sequence. If you're willing to kind of part the branches and look clear, okay, I see. The plus 8 at the end just means I'm adding 8 each time. Correct. Now, a sub n minus 1 is basically saying this. So let's say you go to a sequence and you go to the nth term. That's called a sub n. What comes right before n? And don't quote the alphabet to me. What number is right before n? No, you're on the right track. Would you? Nope. Would you agree if I were making a list of numbers that if n was in a list, that whatever comes before n has to be n minus 1? If you were counting, let's just say you were counting and I went like, okay, here, let's start counting, and not trying to insult your intelligence, just saying, let's literally start counting so I can prove this to you. So first term, second term, third term, 1, 2, 3, 4, 5, 6, 7, 8. Would you agree that 6 is just 7 minus 1? Would you also agree, would you be so kind, that 5 is really just 6 minus 1? So if the number here is n, then the one right before it is n minus 1 by default. You agree? So what it says in the yellow box is every term is 8 more than the term before it. And you might say, well, where does that come from? Well, right here is the term before. It would be 8 more than the term that comes before it. Now, I don't want to go and talk too much more about this because there's a real risk now that I'm going to talk myself. I've already got Aiden to put his dang head down, and I need that to change. He's good. He's back now. So let me tell you what sucks about recursive formulas. First off, I hope you mildly understand the following statement. Every term in this sequence is going to be 8 more than the one that came before it, right? So let's say that I asked you to find the 95th term. Here, if you are still listening, you're about to come to understand why recursives are not as cooperative as explicits. What do you know about the 95th term? I'll get you started. I know that the 95th term is 8 more than the 94th term. Are you okay with that? So then you're like, okay, well, I'll just take the 94th term and add 8 to it. But then you're like, well, crap, what's the 94th term? All I know is it's 8 more than the 93rd term. So now you're like, okay, good. So, okay, so what's the 93rd term? Well, crap on a cracker. The 93rd term, all I can say is it's 8 more than the 92nd term. This madness could go on forever. What I'm trying to tell you is that recursive formulas kind of suck a little bit because you have to know this term to be able to find this term. In a recursive sequence formula, every term is not based on a formula that lets you go where you want. Every term is based on the guy that came before him. What I'm telling you is you cannot find the 40th term if you don't know the 39th term. Right, this was supposed to say recursive. I'm so sorry. That's mistake number 8 for the day. I'm going I'm going for double digits. What? Oh my God. It's a recursive formula. Yeah, sorry, that's mistake number 8. Hey, I still got a solid. I got tons of time. Double digits, baby. Here I come. I'll buy myself something nice after work today to celebrate. Maybe a thing of nachos or some Mike and Ike's. I had Mr. Jim's last night. Do you understand the drawback of a recursive formula? What do you need to find the 12th term in a recursive formula? You get it. What do you need to find the 85th term in a recursive sequence? And I'm like, well, dang it, what do I do if I can't find the 84th? Because I need the 84th to find the 85th. I'll be honest with you, tomorrow's lesson is going to more focus on that. Tomorrow's lesson is after we've gotten our heads around this recursive nonsense. Tomorrow's going to get a little rougher because I'm going to ask you to do tomorrow what I'm kind of passively asking you to do today and telling you can't do. I'm going to give you a recursive formula and ask you to find the 45th term. And I'm going to show you how to do that tomorrow. There's a lot of things going on in my head. So let's get into what we're doing today. Are you ready? Have I lost you completely? That's good, because if that didn't lose you, then we are home free because the rest of today is cake. So today should feel a little bit like a vacation. I wanted to get that awkwardness out of the way. That, my friends, is a recursive formula. And his drawback is that to know a term, sorry, you got to know the term before him. And that's often not what we know, right? So having said that, let's get to it. So here are some examples I conjured up for you. And this should feel nice and relaxing. So if a sub 1 equals 2, and a sub n equals a sub n minus 1 plus 2, find a sub 6. Some of you are going to look at that and say, you lied. Liar, you said this was going to be easy. It is. You just got to get past all the language barriers. So I'll let you get that written down, and then I'll show you how easy it actually is. So first off, and please don't yell the answer at me when you get it before everybody else. Okay, I'm not going to be interested in that. So in the red box is I'm not going to mess this up this time. That is our recursive formula. Can you tell me and I'd really like it if all 7 of you could answer this question, not just 2 of you. Can you tell me from what's in the red box how this sequence behaves? Say it again. And why do you know that, Aiden? Right there. So that's how simple it is with an arithmetic sequence. If it's recursive, it's so easy to just look at the end and say, so that's how the graph, I call that the behavior number. The plus 2 that I put a green circle around says this sequence increases by 2 each time. Can you tell me, based on what's on the board, what the first term of the sequence is? You should know this language by now. Whenever you see someone write a sub 1, what they're saying is incoming first term. So right there in that yellow oval, it says the first term is 2. Now, what did we decide the behavior of the sequence is? Aiden told us. It goes up by 2. So what's the next term? 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 And my friends, I asked you to find the 6th term. Guess what? That's the 6th term. His name is also a sub 6. The answer is 12. So recursive sequences in this context, they're not that bad. Where this would be bad is if I were a jerk and I said, okay, I want you to find the 1294th term. This one for a math person wouldn't be that bad. But for something else, it could get a little nasty. Today's are all going to be find like A6, find A sub 8, find A sub 4. Super easy. Okay. Let's go again. If A sub 1 equals 8 and A sub n equals A sub n minus 1 minus 4, find A sub 5. The key here is, again, the language issue. So let me just ask you some casual questions. Where does the sequence start? If you can't answer this, then I have failed you so badly, and I'm so sorry. What is the first term of the sequence? What is the first term of the sequence? It is 8. Like, and again, I just can't help but point this out. It's right there, dudes. A1 literally means the first term is 8. What is the behavior, Dalton, of this particular sequence? It goes down by 4. It just means that every term is 4 less than the term that came before it. That's what the language says. And so when I write out the sequence now as a set of numbers, here they come. 8 is leading the way, and what's the next one? After that, after that, after that. And guess what? That's our guy. That's another thing that maybe I don't say often enough, just to get rid of some of the stigma of the language. When you find the 5th term, understand you have found A sub 5. That's what that means. Okay? Let's look at some geometric recursive sequences. I would generally just put A sub 5. I would put whatever someone asks me to find. How's that? That work for you? Yep. Okay, let's switch over to geometric. So this time, we're going to say that A sub 1 is equal to 6, and A sub n is equal to -3. Again, I have to, you probably want to know what we want to find. How about this? Let's find about A sub 7. Deal. So let's talk about the language. It's the hardest part. What's the first term? Where does the sequence start? Great. And can you tell me, I'm changing gears on you here, can you tell me based on what you see up there what the behavior of the sequence is? Correct. This is a geometric sequence. It just says, I mean, right here, I'll put a little red box around it for you. This says to take the term before, multiply by -3, and you'll get the term after. That looks pretty geometric to me. So if I were going to write out the sequence, which today our approach is to write out the sequence, because today I'm not asking you for the 37th, 7th, 5th, 8th. It takes like 20 seconds. So let's begin writing the sequence out. 6, comma, here we go. -18 is next. Next. Nope. Nope. Positive 54. Thanks, Diedrich. Then let's take that times -3. What do we get? -162. And by the way, I'm only at A sub 4 right now, right? So I got a few more to go. What's A sub 5 going to be? Positive 486. If you guys don't have calculators out, you're going to make me do these in my head. Don't get mad if I miss them. Okay, what's after 486? I'm leaving my comfort zone now. I'm not buying that. I don't think 3 times that could possibly be over 2,000. In fact, it won't even be over 1,500. Now that I would buy, -1458. And let's see, let's make sure we know where we are. 1, 2, 3, oh, that was 4, 5. Okay, we just found A sub 6. That means our guy is right around the corner. What's that times -3? 4,000, say it again. Guess what? We did it. We found the 7th term. And it's a pretty grungy, dirty way to do it. But honestly, at this point, just trying to get you to understand the recursive language, this is what today is going to look like, is giving you the language of the recursive formula. Like, there is the formula. Go find me the 5th term. Let's practice that. Let's practice that. So any questions on this so far? All right, the second half of your Delta math is going to be, I'm going to give you a sequence and you're going to write for me the recursive formula. So let's do, I think I have 5 or 6 of these that I want to do together with you. So here we go. The formula is what your job is. So here is the sequence. I'm kind of putting a lot on your plate here today, but don't worry, I'll be done. I bet I'll be done in 5 or 6 minutes. So, yeah. So what we're doing now is we're actually writing the formula for this particular sequence. And to be clear, we are not writing any formula we want. I don't want you writing the explicit. We are writing the recursive. To find any term in the sequence, a sub n. You will not believe how easy this is. You might already know how easy this is, but I've got great news. This is easy. I'm not supposed to say that as a teacher because then kids feel dumb when they don't get it. I'm just telling you, you're going to do fine. So a recursive sequence, as I clumsily tried to convey to you about 10 minutes ago, consists of two parts. There are two things that you have to do when you give someone a recursive sequence. Step number one, job number one, is you always tell someone what the first term is. So there we go, halfway home. When writing a recursive formula, you have to tell someone the sequence starts here. Yeah. We also have to tell them how the sequence behaves, and it will look like this. Any term is equal to the term that came before it plus 3. Would you agree? I mean, if you can't figure out that 8 added 3 makes 11 and 11 added 3 makes 14, you and I probably have some much different fish to perhaps fry, right? But you can see once you identify that the behavior is arithmetic plus 3, then all you got to do is know the language. And I'm going to put a box around this. That is how easy it is. One example, done. That's how you write a recursive formula. You tell someone two things. Here's where it starts and here's how it behaves. Done. Let's go again. I'm going to try to have a little less involvement with these. So that one, I feel like I just plopped it out there. I want you guys to take more of this one. Let's do it. By let's, of course, I mean you. Please write the recursive formula for this particular sequence. ¿Qué es la primera cosa que tenemos que escribir? Primero, ¿qué necesitamos? What's first thing? What's first thing we need? You said the right number, but give me more. Now that's a sub 1 equals 15. That's the first thing we write is just we say, there's the first term. You want to be able to, if you want this, when you're done, you want to be able to have this part not on the screen, and you want to hand your formula to Mr. Manlove and have him understand where to start and where to go. That's the goal. So can someone write for me the other part, the a sub n part? I'm ready. Check. There it is. Got it? Makes sense? There it is. This is what you'll type into Delta Math. You'll see when we get there. There's a box to type in a sub 1 and there's a box to type in. And if you wonder like, well, how am I supposed to type this in? There's actually a button right underneath the answer box that says a sub n minus 1. You just click that dang button and poof, it goes in. It's like super easy. All right, let's go again. Our next sequence is 3, 6, 12, 24, dot, dot, dot. What do we write first? There it is. Tell someone where to start, for God's sake. Now, the rest is not where I start, but how do I behave? How is every term being created from his predecessor? Correct. Can't disagree with that, right? 3 times 2, 6 times 2, 12 times 2. That will never change. I won't even need parentheses. What's it going to say? That's it. Hey, and if it makes you feel better, I'm going to put this in yellow so well, maybe red so you can really see it. If it makes you feel better to put a time sign right there, go ahead. But in algebra, we don't often, if things are just numbers and letters or multiplied, we usually stick them together. Even if you put it like this, I don't like it, but I'm not like not gonna take points off for it. Right? You feeling how easy this is to write in a recursive formula? Yeah, I figured. I got three more. Let's knock them out. You might wonder why. Well, you'll see. Uh, next one is 200, negative 100, 50, negative 25. Remember, please, that when we write formulas like this, division does not exist. So when you and I speak casually, you're allowed to say, yeah, it feels to me like every term is being divided by this or divided by this. But when we go to actually formally perform, we need to express everything in terms of multiplication, right? What does 200 get multiplied by to become negative 100? Negative 1/2. If you multiply it by negative 2, it's going to become negative 400. So remember, if you want something to get smaller, you have to multiply it by a fraction. So what I see going from here to here is that I am multiplying by a negative 1/2. I am going to go over there and tear whatever is on your shoe that is tapping the desk. I've been surviving it for like 24 minutes, just going, she's going to stop, she's going to stop. Thank you. I tried to just let it go. I couldn't do it. No, you don't have to be sorry. That's probably more a me thing, but still. How does negative 100 become 50? We multiply by, you guessed it, negative 1/2. How does 50 become negative 25? Again, we multiply by. So, all right, let's do this. Let's write a recursive formula. What do we start with? Love it. What's the recursive, the actual meat and potatoes part of the formula going to say? A sub n equals negative 1/2. Done. I'm always scared to teach this because I know how I felt when and maybe I just was maybe I struggled as a student or I had a teacher that maybe we weren't jiving, but I come into this lesson scared because I know how quickly it can snowball away from you. All a recursive sequence is intended to do is tell someone where to start and what to do. Start at 200, multiply by negative 1/2. You're on your own now, little tiger. Go off. You're fine, Micah. It's okay. Let's go again. I wanted to make sure we got two in a row where we don't walk away not understanding the idea, what division really means. So quickly, what's a sub 1? 243. Good. And then the someone other than over here would be nice if I heard from like Haley or Diedrich or Evie. Like, no, for real. Like, let's spread this around. Or Peyton. Be nice if one of you guys wanted to chime in. What's the meat and potatoes part of our formula going to be? A sub n equals. Yep. Nice job, Evie. Thank you. You guys are silent, but it's always good when you do chime in that I know that your silence just means you're just taking it all in. So nice job. Have you ever done this before? Sequences? Yeah, not bad. Thank you for your input. Let's do one more, okay? And this one I'd like to hear from either Diedrich or Haley or Peyton. It is nice. I know I go through this in all my classes where it's always like the same people. And let's not race each other. Let's spread the joy of participating around the room. I finished you off with 3 or 4 geometrics in a row, right? These are all obviously not arithmetic because it would go -5 plus 20 minus 80. Like, are you kidding me? That's not arithmetic. Clearly geometric. So you want to help? What goes first? Equals. Yes, you're exactly right. So the first thing you say, as obvious as it is you point out this is the first term. Now, what would you say is the behavior? If you can get some help from Haley and Diedrich if you want, but how is this sequence behaving? As I bounce from here to here, what did I multiply by? Because it got bigger. Like 1 becomes bigger to become a 4. I know it's a, let's get this clear out of the way. It's a negative, right? Because it's, but what do you multiply 1 by to make 4? So I see that multiplying by -4 carried me from 1 to the next. Does that work again? It does. Look, if I multiply by -4. So when we talk about recursive, we talk about behavior. Clearly, this sequence has laid down his himself and said, my purpose is I am times -4. Like, you want another term? Take the one you see, multiply it by -4, right? That's his behavior. You want to give it a shot to write the recursive, the meat and potatoes? You don't have to, but it's up to you. I would take it from you or Haley or Dietrich, any one of the three of you would. A sub n, you could just say an, either way, I'm fine. Equals what? Nope. Yep.
I was like, that's number 9.
That's 9. But I'm almost at the end. I'm gonna make it. Sorry, -4. Oh, it's my bad. -4.
And then
You got this.
yeah,
A n minus 1. Yeah, it's not a -1. It's a minus. That's it, guys. That's how easy recursive is. Tell me where to start. Tell me what to do. That. So again, if you took Mr. Manlove walks in the room right now, and you give him that, he can't see right now what's above there. He can't see the list that we made. But if he knows his sequences, which he does, he'd know that he'd go, okay, you want me to start at 1? So he'd write 1, and then he'd just start hitting them all. Times -4, boop, times -4, boop. That's how a recursive gets understood. Nice job. You guys good? All right. Your assignment is on the delta math, and I don't expect you to get it done today. Perhaps, let me stop the recording.